This is a short video to talk about how we name and write formulas for covalent compounds. In contrast to ionic compounds, where the atoms are held together solely by electromagnetic attraction, in covalent compounds there is a physical bond between the atoms in the compound. The atoms share electrons between each other. That means that they are actually physically connected to each other. Now, these types of bonds occur between nonmetals and to a limited degree between nonmetals and metalloids. You're not going to see covalent bonds in our class between metals and nonmetals. All right. Are there some? Yup. Farther on in chemistry, you can get to that. But for us, it's mainly going to be just nonmetals binding to each other. So, big difference here is we're not looking at the lowest whole number ratio for the formula. The formula in a covalent compound is the total number of each element in the compound. All right. It doesn't get down to the whole number ratio, the lowest whole number ratio like we did in formula units. You can do that for covalent compounds. That's what we call an empirical formula, but it's not a lot of use in covalent compounds. Covalent compounds are discrete entities, unlike ionic compounds, which are repeating matrices of charges. Covalent compounds are discrete entities, so we need to know what makes up each discrete entity. One of the ways that we're going to do this, and the major way we're going to do this, is we're going to use prefixes to say how many of each element we have. Now this differs significantly from what we learned in ionic compounds. In ionic compounds, we didn't have to state how many of something we had because the charge allowed us to determine how many we would have to have, because we figured out how many we needed to get to a zero net charge. The atoms in a covalent compound aren't charged though, so I don't have any charges to balance. This is a common mistake students make. Often students will try to balance charges with the covalent compounds and they'll be like, oh, oxygen's got a -2. Nope. Oxygen is not charged in a covalent compound. Sulfur is not charged in a covalent compound. Nothing is charged in a covalent compound. So we can't rely on balancing charges to tell us how many of something we've got. We've got to explicitly state it. Now to do this, we're going to use the Greek prefixes for numbers. I'm only going to make you learn up through 8, right? So mono, di, tri, tetra, penta, hexa, hepta, and octa. These are prefixes that modify a word to say how many of them we have. Most of these are pretty straightforward. Most people knew these before they even came in. Tetra and hepta are probably the ones that people don't know. But for the most part, people get it. So how do we do this? Well, naming covalent compounds is you take the two, you put the one that is farther to the left on the periodic table as the first one, the one that's farther to the right on the periodic table as the second one, and then you use the prefixes to name them. We're only going to name what are called binomial compounds, compounds that are composed of only two elements. All right, so let's look at a couple of examples. So here we have NO3. So I have one nitrogen and 3 oxygens. I'm going to call this nitrogen trioxide. And I know there's a question in your head already. We'll come to that in the next slide, but I just wanted to give you a couple examples before we go at why it is the way it is. So second one, I have 2 phosphorus and 4 oxygens. So we're going to call that diphosphorus tetroxide. And the last guy, I have 1 carbon and 2 oxygens. So we call it carbon dioxide. Now immediately looking at these names, you got a couple of things that come in your mind. You're like, okay, why is it trioxide and not trioxygen? The second one is always converted to the ide form. So oxide, phosphide, nitride, sulfide, right? Carbide. And then going down the halogens, you'd have fluoride, chloride, bromide, iodide, right? The second thing a lot of people go to, and we're going to talk about these rules, second thing a lot of people go to, and is those examples, if I had 1 in the first one, I didn't call it monooxygen trioxide, I called it nitrogen trioxide. Well, grammar rule, grammar rule is that if the first element only is 1, then you drop the mono. Now a subtle one that a lot of people don't get right away, so this is an example of why of us not using mono in the first one. Subtle one that people get is in the second word here, tetroxide. Notice the prefix for 4 is tetra. So why isn't this tetraoxide? It's a quirk of the grammar, but you don't put AO together. So if you would end up with AO joining the prefix and the base word, you drop the A and it becomes tetroxide. Right? So this typically only happens with oxygen. So just be alert to that. You drop the A in those cases. All right? And the last guy here illustrates the last rule again. We've used oxygen for everything else, but something like fluorine would become fluoride. So carbon tetra, because there's no AO thing, tetrafluoride. Right? So these are a few tips on how you name and write the formulas for covalent compounds in Lab 4 plus also in Unit 2.